It's a trilateral partnership between the UNESCO in Paris, France, and the University of South Africa, UNISA, and iThemba Labs, which is a national facility of the National Research Foundation of South Africa. If I try to highlight some examples that we are working on, I would like to more or less to highlight this typical case of coatings that we are synthesizing. These coatings are smart materials. If we coat a window with such a material, when it's hot outside, the heat is reflected from the sun. And when it is cold, the heat is transmitted. So these coatings, once coated on a window of a car or a building, it acts like a smart air conditioning. Other materials on which we are working are materials for solar power technology, such as these ones, for example. As you can see, these coatings are black because they have a tendency and the property to absorb light from the sun and to transfer it in a form of heat. And these coatings are mainly used for the what we call CSP technology, this concentrated solar power, which is the other form of solar conversion parallel to the photovoltaics. Likewise, in these activities, photonics, we synthesize and design and engineer materials which can be used to, such as this one, to purify water, contaminated wastewater. And these nanomaterials, once you disperse them in contaminated wastewater, you expose them to the sun, the water is purified and it's drinkable in effect. An additional activity that we are conducting, which is related also to energy sustainability, is what we call nanofluids. A nanofluid is a fluid which contains nanoparticles, metallic nanoparticles in general. And because a fluid such as this one, an oil, an engine oil, it has a low thermal conductivity. There's a huge loss of energy via heating, and therefore high consumption of fuel. The idea is to ensure that the thermal conductivity of the oil in the engine is higher, is enhanced, and so therefore to incorporate in it nanoparticles of metals, and generally speaking copper. By doing as such, we combine the viscosity of oils, which have a low thermal conductivity, as you can see here, to nanoparticles which have a high thermal conductivity. And therefore, by doing as such, we obtain a nanofluid, and doing as such, we reach high thermal conductivities, and therefore high efficiency, less loss in terms of heat in an engine, and therefore less consumption of fuel. This will be able to be translated to a marketable product and contributing therefore to an energy sustainability worldwide. We need to use some large facilities, and some of them is the accelerator of iThemba Labs here at the Material Research Department. We use mainly techniques that call the Rutherford backscattering, DIXI, photo-induced X-ray emission, as well as air dielectric recall detection analysis. These techniques, the bulk of them, they allow you to have elemental analysis of the thin films and the nanostructures that we have synthesized. That allow us more or less to check about the quality and therefore the efficiency of their physical properties in the future. And in addition to this experiment that we do here, which allow us more or less further to apply to very large facilities worldwide, that is a synchrotron radiation type techniques. But this is a major milestone before going that route.
Professor M. Maaza's research laboratories are host of postgraduates, postdoctoral fellows, and several senior scientists, mainly from Africa and the South, including war zone countries and underdeveloped nations with a significant female fellows. Professor M. Maaza is a Fellow of the European Academy of Sciences, the African Academy of Sciences, the Royal Society of Chemistry, the New York Academy of Sciences, and the Islamic Academy of Sciences. Recently, Professor M. Maaza has been elected as Fellow of the Indian Academy of Sciences.